Welcome. This is the Senior Project Final Design video for the Nucraft Racking System redesign. We are Team 14. Our team consists of Dugan O'Donnell, Tyler Stassines, Daniel Johnston, and Brooke Becker. Our sponsor contact at Nucraft was Tyler Roke, and our faculty advisor was Dr. Jafari. The overall goal for our project was to create a new racking solution for the standard conference tabletops that improves upon the safety, mobility, setup time, and quality issues that they're currently facing. This project had a number of major specifications. These included that the rack needed to accommodate tabletops that had widths ranging from 20 to 60 inches, lengths of 60 to 120 inches, and must be able to withstand static loads of 300 pounds. The rack also needed to allow for tabletops to rotate a minimum of 70 degrees in both directions. This rack is also transported throughout the shop floor by multiple operators, so it needs to be moved using 50 pounds of force or less. During the ideation and design phase of our project, we encountered several significant challenges. The rack is utilized by multiple team members throughout the production process, so a wide range of perspectives needed to be considered. It was essential for the design to balance strength and durability with lightweight construction for ease of transport. Additionally, the rack needed to provide open access to both sides of the tabletop to accommodate sanding, painting, and finishing operations. While mobility was a key requirement, the rack also had to remain secure and stationary when placed on pallets. Lastly, in design we found it difficult to determine the areas that would need to be protected most during overspray and the extent at which those areas needed to be designed around it. During the build process, we found our biggest struggle was factoring in tolerances in the metal fabrication, as Nucraft requested all metalwork be completed by their own department. To overcome these obstacles and satisfy Nucraft's specifications, we designed an A-frame style rack that utilizes the design and overall functionality of Nucraft's current rack design with improved technology and safety features. To accomplish this, the rack was designed with lightweight 1" by 1" steel square tubing for the frame to ensure strength while maintaining a low weight. The rotational subassembly was designed to incorporate a 2" by 2" 80/20 aluminum extrusion for customization, bushings for smooth rotation, and locking shaft plates/pins for adjustability and operator safety. The mounting subassembly consists of 80/20 glides for adjustability, a handbrake to secure the glides once the designed location is met, and a formed bracket to create separation between the 80/20 extrusion and the tabletop for easy access while in production, and a formed component to create a structural surface for the top to be mounted to. Retractable casters were used to allow for easy transportation when on the ground, but also to ensure the rack was stationary when positioned on the pallet. The first subassembly we're touching on is the mounting subassembly. This consists of an 80/20 glider, T-nuts, mounting brackets, and a mounting plate. This assembly is the main component that interacts with the tabletop. They are also able to slide across the 80/20 extrusion for adjustability depending on the size of the tabletop, as you can see by the clip here. The tabletops get fastened to the mounting plate using a screw on either end. They are designed to withstand the forces and moments of the table in all rotational positions. The next subassembly is the rotational system. This assembly consists of two bushings, two safety plate assemblies, the 80/20 2" by 2" extrusion, two mounting subassemblies, a pin plate and limit plate, a locking spring pin, a stationary safety rod, and a variety of hardware components. This system allows for the tabletop to rotate safely and smoothly in both directions and to the specified degree. The locking mechanism of the rotational system consists of the pin plate, limit plate, locking spring pin, and stationary rod. The pin plate allows for the table to be rotated and locked in a number of positions. The limit plate functions as a safety stop if the locking pin fails, preventing any potential damage or injury to the rack, tabletop, or operator. It is also utilized during the table setup for ease of adjustment while the table is being attached. In conclusion, the final design is able to meet all of our project goals of improving the operator safety, rack mobility, setup time, and overall quality of production. Overall, we are pleased with the outcome of this project and are grateful for this opportunity Nucraft has given us to redesign such an important part of their production.